Hi guys, this is Paul with Tweaktown. We're back here at Flash Memory Summit 2014. I'm sitting down with Kent from SandForce. It's been a pretty busy year in the flash industry, and a lot of the noise that's been coming out is there's been some pretty significant mergers and acquisitions. We're seeing a lot of consolidation. And of course, LSI SandForce is not immune to that. I hear that you guys are going to come into the Seagate family. Can you give us any words on how that acquisition is going or any information?
Well, so far it looks like it's going to go through, and planning right now says we should be in the fold in early September.
Excellent.
And we'll continue operating as we have been.
So we already have some products of course, in development with SandForce. So you guys are working on the Griffin right now that is slated for release sometime later this year.
The SF3700, that's
Yes.
right, yep.
Okay. You guys are dealing with some unique challenges with performance. Right now there's a little bit of, I wouldn't say it's misinformation, but there's some people who don't necessarily test storage devices in real world applications. A lot of the benchmarks are fairly standard. What would you recommend for guys out there who are testing and writing SSDs to work on to highlight real world performance?
Well, and you guys, I think, have touched on it quite recently. There was a recent test, July, I think you did that, you published that July 21, if I recall. You did some analysis on multiple applications hitting at the same time, which essentially means that you're getting both reads and writes. And you know, I think that's a key element. I think you've identified some important things to test within an SSD. Because if you think about it, you know, inside your computer, it's not just doing one thing. You have your operating system managing a whole slew of applications. In fact, just last week, I wanted to find out for myself exactly how many little DLLs, executables, and things are operating in the background. On my laptop computer I use at work, I counted no less than 140 applications sitting in the background. Now, it's not like, hey, just for this particular test, I decided to load up everything. No, this is my typical daily boot. And so any one of those apps can do a read or a write at any time to the SSD or whatever storage device you have. So when people talk about, hey, I'm going to do a real world test by loading up this one application and seeing how fast it runs, well, if you're only testing one app, it's typically only going to do a read or a write. And so you may find, hey, this architecture works great if that's all I do is one thing at a time. But as soon as you look at multiple applications or simulate, you know, some kind of read-write mix, that's when you see what's really going on in that architecture.
Well, it was pretty surprising in our testing that, of course, the SF2200 was it delivered a lot of robust performance, especially in those mixed read-write accesses. As some devices, if you do all read, they're way up here. You do all write, they're way over here. But as soon as you mix in either of the two, the performance just drops. So I think that that's definitely a strength of your design. Is that because you designed the controller to handle that type of workload better? Or?
Absolutely, and you know, just kind of extending what you were saying there, in the graph that you guys showed, you could see that the 2200 was clearly able to maintain that performance across that mixed read-write, and that can only be done when your architecture is designed to support both things happening at once. And you know, this is rocket science. There's a lot of things going on in there that have to be accounted for. And if you don't already have the architecture designed to support that, it's hard to come in later and add it in. It has to be designed in from the beginning. And so, you know, I was actually surprised to see how well a SATA interface performed against I believe that was a 4-channel PCIe from somebody else. And so I think that is even more proof that it's within the architecture to be able to support that bidirectional nature, especially for PCIe. But SATA is unidirectional. And we were still able to perform almost twice the speed.
Twice as fast, yes, against a PCIe SSD from a SATA SSD. It's pretty impressive.
Yeah.
So, and I think some of this kind of an inherent capability of your drives to be able to handle mixed read-write. You know, you were alluding to PCIe is a new interface that a lot of people are using for storage, and it can read and write at the same time. So when you guys release the new series, you should really even see even more gains in that area, correct?
Absolutely, yeah. If the architecture is designed well, then your combined performance will be no less than the worst of the two extremes. So if your write performance was 800 megabytes per second for sequential, and your reads was 1800, then something in between should be above 800. It should never go down.
Yeah, it's kind of that sustained performance. One of the things that SandForce has always been great about is you guys have a wide compatibility. I mean, old NAND, new NAND, future NAND. You guys are always looking at different ways to become interoperable with new types of NAND and existing. Now, a problem that we're seeing as they continue to shrink NAND and it becomes more cost effective, but we're getting increased bit error rates. It's harder to deal with some of these new NANDs. What type of approaches is SandForce taking to address those needs?
Well, in fact, that's a key part of our technology. We have our error correction technology we call Shield, and with that we have hard and soft LDPC decoding with DSP technology. And so that, in addition to a few other things that we actually announced at Flash Memory Summit last year, we believe that those combinations can really take advantage of Flash, even though as it shrinks, as you said, it gets higher and higher error rates. And in fact, just recently we did some analysis looking at just how many cycles can we take Flash, not necessarily supporting a full endurance of enterprise or consumer Flash, but we think we're onto something where we could take advantage of Flash even as short as a very short duration, which would be maybe associated with a caching environment. So if you imagine a cache for a hard drive really only has to keep the data for, let's say, 24 hours. After that,
constantly changing.
You're constantly flushing the cache. So if you had a way of using Flash and your retention time was only 24 hours, let's say, wow, you could take that cycle count a long ways past the manufacturer spec and still have it be very, very viable product.
So yeah, you can extract more data from it.
Absolutely. And so you can use it for a lot longer. So then when you figure out your cost per gigabyte, you don't have to completely replace it, every couple of years. You could actually extend it out quite a bit. And then therefore you can deploy that much more because the amount you spent will be used a lot longer.
Yes, I've always noticed that with client-side devices, they have to retain data for 1 year, whereas enterprise devices only have to retain data for 3 months.
Exactly.
So there's a big difference there. I mean, in always-on enterprise environments and situations like that, that could really help extract more value from the solution, correct?
Absolutely, and those ratings are only when the Flash is at its end of life. So at the beginning of life, it's very robust and capable of doing so much more. And it's not until it hits the end of life that you really see those shorter and shorter endurances. So with the Shield technology, you could even design something where the cycle count can get really, really high because your retention time doesn't need to be that significant in, let's say, this caching environment. So, if you could get 10 to 15 times more cycles out of the Flash in that caching environment, you effectively reduce the cost per gigabyte by that same amount.
And that could even open doors to other types of data storage. I remember last year it was a pretty big news when Facebook kind of made a public plea for very cheap Flash to actually keep cold data on files that may be read once a year. And they're looking at keeping that on, essentially TLC or even maybe in USB class NAND. So something like that, you think that could work in an environment like that?
Well, and that's interesting because in that case, you're looking at cold storage that gets written very few times.
Yeah.
So theoretically, at the beginning of Flash life, it has a relatively long retention. So if you didn't cycle it that often, the Flash stays with a relatively long retention time. Now, technically, once you hit that retention time, you just need to effectively rewrite it. So if you had a system that was maintaining it, in theory, you could possibly design a system that took care of that. And then as the Flash aged, of course, you would need that robust, maybe Shield technology to keep track of the error rate and to still maintain over time. At some point, you will wear out that Flash, and that's the point where you could, rotate it out. But you've already saved so much money that I think you've already gotten the benefit.
Awesome, that sounds great. I mean, Flash is exciting right now. It's becoming so much more pervasive, and there's new applications for Flash that they come up with every day, and LSI is right there among the leaders with SandForce. We appreciate your time.
Well, thank you very much. Thanks. All right.